recording about all this.
All right, so let's go ahead and get started. But I am going to start with sharing with you pictures of modern classrooms, so that we can have something to dream on.
It's always nice. When the dreams aren't
That's
bad.
all we have got. That's all we have got. All right, so the building stuff is new building over here. Okay, so these are some of the presentations that the architectural firm has done to show us.
Why couldn't they have done this about 5 years ago? Then I could take a minute.
Yeah, but can't. They were not ready. It's not like they don't have the money. They have the money to do all the renovations, new buildings and whatnot. But the campus cannot all be renovating all at the same time because they have to dislocate people. They have to basically relocate people to different parts of the campus. And you cannot just have all the buildings torn down at the same time. That would not be doable.
You need another campus to support it.
Exactly. You need a swap campus to support that. Okay, so we don't have enough space to do all that unless we can camp out on top of the Davies Hall, set up those little tent things. We'll have classes over there. It'll be kind of cool.
Until it gets really cold, some of
Yeah.
it starts getting frostbite on the hands.
Yeah.
It'll be interesting. Not good. Interesting.
So anyway, this is the presentation that the architects presented last Friday. So I only got this last Friday. So this is the schedule. So the schedule is project start date is right on time. This is not the meeting yesterday. Last Friday. So the completion of initial phase is going to be done in June, which means that by the end of this semester, we would have all the criteria in, so the architect would know what we're looking for. Project development is here. This is the documentation phase, which is early next year. The approval is July 2017, so next year. So in about a year and a few months, they would have everything done, and hopefully everything is going to be approved, so the construction can start. The completion of construction is going to be April 2019, and that's really, really far off, which means that this is really nothing more than a projection, because it all depends on, how the economy is doing between now and 2019. Because if the economy is doing really well and there's lots of construction projects going on, they may not even be able to hire enough contractors to get this project done on time. On the other hand, if the economy takes a dive, okay, and there are lots of excess contractors and they're all hungry, then we'll get it done before that date, for less. So it all depends, okay? A lot of stuff can happen between now and 2019. Okay, so the research, blah, blah, blah. The 10 fastest growing degree programs between year 2010 and 14. Science technology is plus 49%. Interdisciplinary studies is plus 36. Math is plus 35. Computer science is only plus 32. I don't really understand exactly why. Okay, so a few slides, keep going. Okay, we already know this. So basically this part here, these are the old buildings. They will be replaced by new buildings. And this is not the exact shape of the new building. They have not decided yet. Yep.
The statistics that you just read, is that just for our district, or is it like
No, I think it's
worldwide?
I think the numbers are nationwide.
National?
Yeah.
Because
It's based on Education Advisory Board. So I think it's nationwide. All right, keep going. And this is the sun, the angle of the sun. So the angle of the sun would go from here to here, or the other way around, to go from here to here in the winter, and then in the summer it goes from here to here. In other words, I think they're planning to use as much natural lighting as possible. Okay, especially when the top floor and also the window, the south side of the building, will try to let in natural lighting. These are the walkways, so they want to figure out how people get from one place to another place on campus. and make sure the new building is not an obstacle. Okay, assignable square footage. Okay, so we have about 40,000 assignable square footages for classrooms, labs, offices. I don't know about libraries because I don't think we have a library at this point, lounge and stuff like that. Budget is $16.7 million. And benchmark of student success, how do we make sure that you guys become successful? Strong connection early on, establish a network. And I think they do not mean Wi-Fi. Time spent on campus is directly related to success. Well, there goes all the online classes.
No.
Unless you want to get on campus to take online classes. I mean, that can happen too.
You kind of lose the convenience, but yeah.
Yeah, you kind of lose some of the attractive features of online classes. Increase student utilization of advising, maximize engagement between students and faculty, vibrant space to engage millennials ethos. I think you guys are supposed to be the millennials.
Yeah.
Millennials. Okay.
Yeah, it's about mid to late 1980s to I think about 2005, 2010.
Oh, okay.
At
So
the
you guys
latest.
are right into that. Most of you are in that range. Strong association to unique community. So these are sample projects. These are things that they have done already. So the idea is they want to, instead of just the walkway, we won't have breezeways anymore. Okay. Instead, we'll have indoor, completely enclosed corridors. But they're not just for walking. They will set aside areas where you guys can sit down. There'll be tables. You can do homework and stuff like that. And I will make sure that you have electrical outlets to charge your stuff.
Thank you. So
Okay.
much. Yeah.
The ones coming after.
Yeah. Otherwise, you guys will be fighting over one outlet,
Yeah.
or I will see a tree of extension
Yeah.
cords.
Yeah.
Well, okay. For those of you who have taken data structure, you know what I'm talking about. A tree of extension cords, and the span, what is the name of that thing? The fan out rate is going to be 1 to 6 because that's kind of the maximum of most of the extension cords. So there will be features like this, okay? And this is also another picture. If you can see a little bit right here, I'm not sure whether you can see it or not. But this is the main hallway. But on the side, there are places where people can sit down, talk, do homework, take a nap, that sort of thing. And trust me, you guys won't be the only ones taking a nap. I'll bring my sleeping bag. Okay, and the classrooms will be reconfigurable, hopefully. Okay, so with this one, they have tables and desks that are tiered. The first part of the classroom, which is about here, these are kind of like couches. Okay, so they're pretty low, comfy, but they're really low. The middle part here will be your usual height tables and chairs. The last part here will be kind of more like stools. Okay, so you'll be sitting on stools, and then the height of the table is more like a workbench kind of height. So this way, people in the back will not see the head of the people in front when you try to look at the projector, because instead of making the room itself sloped, we use the furniture to adjust for that. Okay. So in a typical, usual lecture class like what I'm doing right now, that's the arrangement. Okay, so the professor will be in the center, the projector or the projection screen will be like right in the back. A lot of faculty, a lot of professors have asked not to have a projection screen that is on the opposite end of the lecture room that is actually wider than it is long. Because now, I suppose it's a good thing because it forces you guys to have to look at me and then look at the screen, go back and look at me and then look at the screen, so you won't fall asleep as easily. Okay, but most professors have asked for something more like that, where the place where I do the lecture is about the same place where the projection screen is. And I'm going to put in the request to also get rid of the projection screen itself and just use the whiteboard a really wide whiteboard area for projection. Yep.
Oh, no, it's just.
Oh, okay. And I know how people hate to see the glare. Okay, if this is the projection area, many of you, especially the people in the center, will see the hot spot because it is it's reflective. Yep.
In that diagram, in front of the tables, there's like another layer of chairs. What is that?
You mean where the cursor is?
Yeah.
You mean this part here?
Yeah, what are those?
Those are couches. They're really low, kind of couches. Yeah.
That's
Oh,
nap
right,
space. Why?
I think if you roll your credit card, they can even dispense drinks.
Start back ready.
I mean,
Yep. But what I'm thinking is, using one of those, they call those short throw projectors, okay? Short throw projectors are the ones where you don't need this kind of distance for projection. The projector is going to be about here. So that means unless you're trying to look at the screen from down here, you won't see the reflected light, which is great because now I can project an algorithm and I can annotate on the whiteboard itself. And I'll walk away when you guys take pictures. Okay, so this is one configuration and this is another configuration. So they just have different fancy names for that. This is tiered furniture learning studio. Okay, so this way we can have kind of like, I guess more of a meeting kind of setup where people can face each other and talk about stuff. And then we also have something that's more like this, where you have small groups, break out and actually, talk and do stuff.
That's what charter schools have, right?
Sorry?
That's the system the charter schools use.
Which one?
The last one that you're showing right there.
It's the same school. It's just reconfigurable.
No, I'm saying in charter schools.
Oh,
they
in
have
charter
this-
schools.
Yes, they have the same style of classroom configuration.
I've had classrooms like that
I was
here.
thinking plastic back.
It's not, that's
But I'm not going to be the one
Yeah.
moving the furnitures around. The only problem with this kind of setup is if we want electrical outlets in the classroom, where are you going to plug it in? Well, but it's changing because it's not going to be the same position. So I have this crazy idea of in-floor retractable extension cords.
like in the student center?
That's good. That could be dangerous.
Spaghetti code.
Spaghetti tripping over.
Think tree, not spaghetti code.
Well, have you seen the, in some lab classrooms, like in high schools and stuff, they'll have like spools of extension cords in the ceiling?
Yes, I have seen those. Those are typically also used in auto shops. Instead of electrical cord, they have air hoses.
Yeah, there goes.
Yeah.
Yeah, but the problem is it interferes with the screen. So unless you make those things kind of out of the way and not interfere with the screen, that can be a problem too. So I think coming up from the floor is really the best way to do it. We just have to center the repositioning of furniture around certain hub, areas. So you have to kind of, so there will still be some restrictions of how you can rearrange the furnitures. Okay, moving on. So this is an actual real, classroom. Okay, using those type of technologies. Yeah. Okay, so we have more active learning studios. Fancy words. Same thing. Where people can rearrange the furniture. So everything is going to be on wheels. That's the idea. Everything is going to be on wheels. Hopefully lockable wheels.
That'd be nice.
They also want to have nooks like that, so that along the hallway, next to classrooms, people can go outside and actually talk about homework assignments, get ready for tests, just take a break, stuff like that. So on the left hand side, we have a kind of smaller area, where people can just kind of sit down, work on something, and then on the right hand side, we have a larger area where we can work on group projects and talk about stuff. Okay. Moving on. This is really fun for me, maker labs. Okay, so if we can actually end up with a quote unquote messy area where people can do all kinds of stuff, that would be kind of cool.
Again, they have those spools.
Sorry?
They have those extensions cord spools
Yeah.
that go on down there.
Right, I'm not sure whether those are they electrical? Yeah, they look electrical to me.
Makes you wonder how you're gonna get messy in a computer science class.
Spaghetti code.
Better than a processor.
Spaghetti code with sauce and meatball. So not only is my code really bad, but it also has spaghetti sauce and meatball in it.
What you just
What does
grabbed.
that even mean?
So next time when you want to describe someone's code being bad, you'll just say spaghetti code with sauce and meatball.
Well, some nice Italian computer science.
Yep. So they want to make the main area of the building kind of reconfigurable, so we can have classrooms that. So this is the main entryway, and then they can get into individual learning areas. This is not a classroom setting, because the spaces are not enclosed, but they are kind of partitioned in a certain way. It's good for exhibition, but not particularly good for classrooms. If they have movable walls, then it's a different story, because now we can actually have enclosed spaces for individual classrooms. And these are the actual hard walls, so the red ones are the walls that cannot move, the blue ones are the ones that can move. So they're putting all these concepts into the building so that things can be flexible. Okay. And let's see, learning space type A. This is really cool. I would like to see this happen. These are basically specially designed furniture where one end has the monitor. It's like a half circle, but it's not really a half circle. It makes it easier for group discussions where you guys can plug in one computer to the big screen, and then the other maybe 2 or 3 people can look at the same screen and talk about stuff. Okay. So that's this is the actual use of that furniture. Nice looking buildings. This is actually not real. This is a makerspace concept. We don't really have a makerspace, as far as I know. Computer lab, lots of stationary Macs. In this case,
Good paperweights.
paperweights, exactly.
Expensive.
I think by the time we get to 2019, it'll be all bring your own devices. I don't think we'll have computers anymore. Even if the computer, even if there are computers in our computer lab, they should all be laptop computers. There should be no desktop computers anymore, because the price difference is no longer that much. In fact, I would say that by 2019, desktop computers will cost more.
Well, it depends on what kind of stuff you're cramming in there. Like spec for spec, a laptop, a high spec laptop's going to cost you more than
You don't need a good graphics card in a computer lab.
We're not going to play video games that require, excessive GPU capabilities.
Photoshop the most.
Collaboration zone, the dean, Dr. Booth is already sold on writable walls. Okay, so instead of having whiteboards like this entire wall is going to be a whiteboard material.
Cool.
Okay, and also using a short throw projector. We don't have a separate screen either. Okay, it will just be the same wall for projection and also for writing, which I think is going to be great. I personally put in the request to use directional lighting, so this way, the lighting for your writing is not going to wash out the main screen itself. So that way, it's a little bit better. And we can also make it a section, make it sectioned, where the center part where the projection is, when I use the projector, I can turn off the light to light up the whiteboard. But when I do use it just as a regular whiteboard, I can turn that light back on. So this way, I have contrast control over different panels of the same wall.
Though for that to work properly, since you said they're going to try and make use of natural lighting, wouldn't you have to close the shades for that to have the optimal
Possibly
effect?
we have to turn off some of the shades from the outside. This is a lab classroom combination. Some of you may be taking classes where you have kind of like a lab, like this class. Okay, so the lab portion can be in a different section where the partition is glass based, but it is removable. Okay, so you can have two classes going on at exactly the same time. One is a lab, one is a lecture. You can also open it up where some people are in the lecture area actually doing some studying and planning. Other people are in the lab area actually doing. And this is a design studio. We don't have engineering moving into the building yet, or at least that's not part of the plan as of yet. This is really cool. These are skylights. These are skylights. So whatever is underneath, they can during the day they will all have natural, just daylight. So that's basically what it looks like from the inside of the downstairs. So they have all these skylights providing the light, and the hallway looks like this. Once again, we have places for people to walk, and then chairs and tables for people to sit down, do homework, or just talk about stuff. They call it breakout spaces. Okay, so that's all the slides that I got on Friday, and then we are meeting tomorrow to set up certain high-level criteria, probably a rough idea of what floor will be what in this new building. The current plan is going to be at least 3-story high. But with enough money, it might go actually 4-story high. Because the additional cost to add one more story, when you have a 3-story building and you're adding one more story, is actually not that much. It's a very efficient use of money when you're just adding one more floor, as opposed to using that money for another building. That's a lot more. So I think the lab and classrooms will be on the first 2 floors, and then faculty offices will be on the 3rd. So any requests from you guys? Yep.
Video surveillance.
Oh, that's already on my plan.
Good.
Yes, it's already on my plan. And we will have the whole place, being monitored.
Well,
So which buildings are being demolished for the room?
All of these liberal arts. So everything that starts with LA is going to be demolished. Yep. Sorry? Anything else? I'm putting in drinking fountains with good filters.
Yeah, right.
Yep.
So on the agenda,
Yep.
they didn't mention the part where everybody has to go to a different building to take their liberal arts classes. When is that gonna happen?
You mean during the construction phase?
Yeah.
I don't think they have that actually listed, but you can probably figure out an approximate time frame for that.
they're probably going to need more.
Because it has to be after the approval, which is after July 2017, and then the completion of construction is here, so it's somewhere between that time frame. So I would say by fall 2017, the construction will begin, and then by summer 2019, we'll actually move in. Most of you probably won't see it unless you come back for a visit.
Or to get another degree.
I'm just gonna try to graduate before they move all the linear out there, because there's no way I'm gonna see it.
Yeah, we're
Yeah.
We're probably going to move in next year. Basically, next fall is going to be the moving. All right. Any ideas? If you guys have any ideas, just shoot me an email. And if you do it before the meeting tomorrow, I might be able to put it into the agenda thing. So, ideas. I also requested lockdown features, of classrooms. In case of any type of emergency, the doors can close and lock automatically.
Panic button? Panic button?
Panic button, release sleeping gas, just in the entire building. I don't care who you are going to sleep.
You are going down.
We are all going to sleep.
That'd be a really terrible combination, like a break-in. Somebody comes in to shoot people and everybody's just asleep. That's lazy.
And they will fall asleep too. All right, so let's talk about the homework assignment. So as you continue with today's lecture, kind of keep that in mind, okay? What makes this classroom not work so well, just keep that in mind. Because I don't see from your perspective much, okay? Because, I'm on this side. All right, so let's go ahead and do this homework assignment, because I think there might be some questions about it. And I'm going to double check the recorder is on. Okay, it is. Because there has been multiple times already that I forgot to check and I did not record. How was this homework assignment?
It was actually alright once I figured it out.
It wasn't too bad once I slept on it.
Okay, well that's good. I mean that's the intention of the homework assignment. It's a little bit challenging where you cannot just eyeball the whole thing and go like, yeah, okay, I know exactly what to do. But hopefully it's not, difficult to the point where, I'm gonna give up, I can't do this. Okay? Alright, so given this is the homework assignment, what is the first thing that you do? You look at this number here and go like, I need to do something about this. Right? You want to convert it into a hexadecimal format. Okay? So that's the first thing you do. Second thing you do is to comment out these instructions, the ones that would not assemble. Actually, you comment it out, assemble the program, and then you go in and then you try to take a look at the memory layout, okay, and find out what those .in, .word, and whatnot is initialized in your memory. Okay, so that would be the next step. And then you look at the result that you need in EBX. You look at the instructions that can change EBX, and then you ask the question: how do we lock down where we are supposed to copy to with the first instruction? Okay, so we're going to do all that stuff today. So the first thing I do is I comment out all of these lines here. This one does not need to be commented out, but I'm going to do it anyway. So now I have all of these instructions commented out, and I can just go ahead and assemble and run the program. So we'll do it AS link and GDB. There we go. You have to put a breakpoint in order to stop the program so that you can examine the memory content. So I will just go ahead and run the program. Now it has stopped. So what I would do is take a look at the memory layout. And you might want to do that in a way that you can capture that. So you can either copy and paste from the terminal, or you can just take a screenshot, because I need to refer to that probably a few times. So we'll do the X command, X for examine, and let's see how many bytes we have to examine. 4, 8, 10, 12, 16, and 20. So there are 20 bytes to look at. I want to look at each byte as a hexadecimal number, therefore the X. And the start location is going to be right here. But I don't have a label for that location, but I do have a label here. L1 is the first byte of this particular thing. So L1 minus, let's see, we got 8 and 12. So L1 minus 12 is going to the start location of the entire thing. So L1 minus 12 is where we have the first .int. And we'll just go ahead and do the memory dump, and it looks like that. Okay? It's useful, okay? So what I'll do is I'm going to copy and paste this, because I know this is going to be useful to me. So I'll do, I cannot do Control C here. Copy, go to a, I have an editor already open, it's just for the other class. Paste it over here, so this way I have a copy, because I know this is going to be useful. And what I'll do is I'm going to list the program again, because I want to see this number in hexadecimal as well. So I'm going to say print /x for hexadecimal. Control C, copy, and then paste. Press the Enter key. I know this is important to me too, so I'm going to copy and paste this also into my text editor. And I keep using the wrong key sequence to do it. There we go. All right. So now I got everything that I need to begin with, and it's time to switch back to the text editor. Well, switch back to the program. Get out from GDB, go back into the program, and take a look at the memory layout at the same time as when we take a look at the program itself. All right. So can everybody see the important part of the screen where I will be doing the editing? Okay, so the first thing we notice is EBX needs to have FF87 as the most significant 16 bits out of the 32. There's only one instruction of the entire program that can change those 16 bits, and that instruction is which one? The move L that has EBX as the second operand. Okay, in other words, this is the only instruction that can put in the FF87. So now the question is, how do we get that how do we get that FF87 into the most significant 16 bits of EBX? The lower portion, I'm not too concerned, because the lower portion can still be changed by this instruction, and then the least significant 8 bits can also be changed by this particular instruction. So I'm not too concerned about the least significant 16 bits. I'm just concerned about the most significant 16 bits, or bit 16 to 31. Okay, so we know it is FF87 that we are looking for, but in memory layout it's going to be reversed because of little endian. So when we look at the memory layout, we are actually looking for 87FF, which is right here. But if I need these 2 bytes to be the most significant 2 bytes of the register, that means I have to start copying from here. Is that making any sense? It's all because of little endian, or the least significant byte is the one with the lowest address. Oh, I'm sorry, I didn't know that this is out of the normal projection area. There we go, better. Okay, so once again, this is nice. It would be nice if I can just do it on a flat surface completely and we'll just get rid of projection screens. Okay, so what is the address of this location? Okay, we know this one is L1 plus 4 plus 3, 2, 1, 0, minus 1, minus 2, minus 3, minus 4, minus 5, minus 6, minus 7. This is minus 8. L1 minus 8. Is that making any sense? Okay. So that means going back to the program, if I were to annotate the program, you can always have another pound sign. It doesn't really interfere with anything. So I want EAX to be L1 minus what again? 8. 8. Okay. So I want L1 minus 8 to be in EAX at this point. But to make that happen, I can only rely on these 2 other instructions. Okay, that's the only way I can ensure that we have L1 minus 8 in EAX by the time we get to the 3rd instruction. Okay, are there any questions at this point? So I probably want to look, what does that mean? Probably. So I want to look for something that is close to L1 minus 8, because the second instruction, which is the add-long instruction with a $sign, basically allows me to do small adjustments. Okay, if I'm off by a few bytes, I can nudge it. Okay, so from the memory layout, or from this particular view, is there anything in memory that is close to L1 minus 8? Or at least L1 dot dot dot? 6. L1 minus 6. Okay, so L1 minus 6 is at label L1 itself. So I want to get it into EAX first, and then we'll nudge it by subtracting 2 from it. Is that okay? So that means we can start with here and say move L1, or move the 4 bytes starting at label L1 into EAX. But what are those 4 bytes at location L1? It is the address of L1 minus 6, exactly. Okay, so the first instruction is going to move L1 minus 6 into EAX. I'm still 2 bytes off, so that means the second instruction only has to make that small adjustment. Yep.
I tried L1 minus 2 on top. Why did it not work?
You try L1 minus
2 on top.
Well, L1 minus 2 is going to specify the dot word 25,000. Because the dot in itself is at location L1. So what is at location L1 minus 2? It is the 25,000 that is at location L1 minus 2. Okay, so that's why that did not work. Because the main idea of this homework assignment, as well as the previous one, is you have to distinguish when do I specify an address and when do I specify a non-address, which is a number that we're doing calculation with, like add, or in the previous homework assignment, we're just literally copying this byte to that part of a register. Yep.
What if you did the L1 minus 2 and then you proceeded to subtract 6 from it in the next line?
That won't work because you're copying from the wrong place. If you L1 minus what again?
Whatever. 2. 2 and 6.
But doing this means I'm going to copy these 2 bytes and also the least significant 2 bytes of this thing here, which is not going to be an address. Okay, let's take a look at the memory dump first. Okay, so this is the memory dump. Okay, what is at L1? This is L1 plus 4, plus 3, plus 2, plus 1. This is plus 0. Okay, this is exactly at location L1. Okay, if you look at the dot int, which means we're looking at 4 bytes here, but remember this is in memory layout mode. So when you read this out as a hexadecimal number in 32-bit, this is what? It is 0040007E. What does that have anything to do with 4000088, which is known to be L1 plus 4?
That's the address of.
Yep.
I got it.
Exactly. Yep. So from the memory layout and using little endian, you can actually get to see, so we are storing an address at a certain location. Yep.
The main goal is to get to L1 minus 8. So on the first one, you can choose any number, right? And then you can do L1 minus.
Why would any number work?
I mean, any number that you know of. On the,
Nope.
the first one.
No, you're completely locked down with this one. You cannot do anything else. Because if you specify anything other than L1,
No, I used L1. But
yeah.
I used one of the numbers, but I used L1 minus, let's say, minus 2, 4, 12. So L1 minus 12.
That's the first instruction
Yeah. L1
here.
minus 12. Yeah, so you know what number you're putting in.
But that won't work because you're not going to copy the right address.
Yeah, but then on the next step, you can go L1 minus a number.
No, it will give you a
seg
seg fault to begin with. Well,
Let's try that.
I've tried it.
I did get many seg faults.
Yeah.
Yeah.
So let's go
Part of the
L1.
assignment.
It has to be L1 because L1 holds an address. Anything
because at
else
location
doesn't.
L1, it is an address, which later on we will use in the indirect operand of the third instruction.
And that's the only place that holds a valid address. So
Yep.
that's why we have to modify it.
Yep.
Got it.
What is prior to 12?
What is prior
Is
to
that random memory?
Garbage?
prior to 12? What do you mean?
Like L1 minus 13 and beyond. Would that be considered
Well,
random
we
memory?
could find out what it
Like, I
is.
think that's
It is
outside
not
the scope.
accessible to your process. It
was.
is not accessible to your process. Okay, do you want the long answer or the short?
It was for me.
Okay, the long answer is when the operating system allocates memory for a process, which is a program in execution to run, it is just taking a chunk of physical memory and say, okay, I'm going to allocate this chunk of memory to this particular process, and it will probably there are some operating system defaults, to determine where to start and stuff like that, but it won't allocate any more than what your program actually needs. So this is a fairly tiny program, and there's a certain quantum that it has to allocate by. So technically, there's nothing before L1 minus 12. If you try to access L1 minus 12, if you try to access any location before L1 minus 12, you get a seg fault.
I accessed location L1 minus 19, and then I added, hold on, I totally just changed this, but I added, I believe 8. So it was 0, it was 0 to start off with, and then I added a negative number, and that actually worked. And then I started modifying the sub W and sub B.
Well, remember, your program has to work when I test it on my computer too.
I tested it on like 3 other computers.
but that's because you're using the same linker
No.
options.
Linker options?
Because your program and my program do not start at the same place. So if you hard code it, what worked for you will not work in my case. Okay, so let's check this out. Okay, let's check it out. So we will do the link, and then we do the GDB, list the program, put a breakpoint on line 8, which is underscore start, run the program. Okay, so now we can try to do an examine on 1 byte in hexadecimal at L1 minus 13. Okay. Oh, okay, so it is mappable.
It goes all the way to like 96.
But in my case, it may not work. Okay, it may not be the same stuff at that random location. Okay, so let's check whether my my answer works here. Put a breakpoint on line 10, run the program. Oops. Continue running the program. Single step line 10, and then we'll take a look at the register EBX. So EBX does end up with FF87 at this point. So this code works.
Yeah.
Okay, but it works for the right reason.
Why? It's because it allocates all of the memory that it
No,
allocates.
because I make use of the label. You have to make use of this label here. And you have to basically you have to copy the content at that label, which is L1 minus 6 into EAX, subtract 2 from that number, and then do this instruction here. That's the whole purpose of this homework assignment, is for you guys to figure out, how memory is accessed by these different operands.
Yeah, it when I was first going through it and drew my own memory map, when I saw the L1 minus 6 being allocated, in my head I was like, oh, so go back 6, and then those bits are going to be the ones. And so I spent about 2 hours figuring out that was wrong.
But now you understand why it is not working.
Sadly.
Sadly. Okay, because, okay, so let's take a look at the memory bus operation, okay, because that will explain what is going on here. In terms of bus operation, okay, the first instruction is doing kind of something like this. So this instruction is really doing, okay, let's copy something to EAX. What am I copying to EAX? It's not L1. It is whatever is at L1. That is what it's doing. Okay? So whatever the expression you put here, it is going to that location and copy that to EAX. But there's no guarantee of anything before L1 minus 12. So if you use anything that's before L1 minus 12 here, that means you're using some uninitialized space or a space that is not up to our specification. So there's no guarantee that it will work. If it does work, it can be working by fluke. It could be just a fluke that it just kind of works out. But this is what I really want you guys to get, is this instruction is doing this, or in pseudo C code, that's what it's doing. Is that okay?
Can you try L1 minus 19 and then L1 minus 8 for the second line?
But that's, even if it does work, I cannot give you credit, because it is the wrong approach to do it. You're not demonstrating that you understand the concepts.
But I had to figure that out. It starts from 0, and then you subtract the number.
Okay, what was it again? L1 minus
19.
19, and what is the second one?
L1 minus 8.
L1 minus 8. Okay, let's give it a try. Link, GDB, it's the program, put a breakpoint on line 10, run the program, single step, and I got the 6th fault. It's a segmentation fault.
Line 10?
Yeah.
Like after line 10 or before?
This is on line 10. Line 10 gave me a segmentation fault, because if I look at EAX, it does not contain a valid address. It is not a location that this process can access.
Well, that sucks.
No, it doesn't suck, because if you continue not to understand what these instructions are doing, then the next exam will really bite.
No, it sucks
That
because
is-
I did make it to the
I understand
to the
you-
right thing. So I mean, I had to know somehow.
But it's not, but you're not understanding the concept that you really should be using to get this done. Okay? Is that okay? Because the location L1 minus 19 is beyond what we already know about the content of memory. So you cannot rely on that. Okay? Are there any questions? Yep.
Can you explain line 9 to us each other again?
Yep, I'm going to do the whole thing. I'm going to write the whole program using that annotation. So the next line here is really literally just adding, well, not like this. That will work. Okay, so this is really just saying EAX is EAX plus -2. Because of the dollar sign basically specifies whatever you specify after the dollar sign is exactly the value that it will use for that operation. So in this case, it's $-2, which means the value of -2 is exactly what I'm adding to EAX. Yep.
So can we just think of it as like decrementing a pointer by 2, like sort of?
Well, okay, that's kind of what it's doing, but it is kind of not such a good idea to think of it as a pointer, because EAX is nothing more than a register, okay? You can use a register for calculation, you can use a register in the next instruction, and use it to specify an address. So there's no such thing as a type associated with a register. It is on the instruction itself. When you use an instruction and use it as an operand, then it will determine how to make use of the bit pattern of a register.
But it's kind of like a low-level equivalent to that, or?
It's kind of like that, but I would just leave it like this. Okay, we are just subtracting 2 from EAX. But at this point, is it a pointer? I don't know. Is it just a number that I will use for later calculation? I don't know. I'm just subtracting 2 from whatever is in EAX. Okay. So the next instruction is the one that really matters the most, because how are we making use of EAX? So this instruction is doing this, okay? I want to go to wherever EAX is pointing me to, starting at that location, copy 4 bytes into EBX. Is that okay? But if I do my calculations, after the first operation, EAX will end up with the value of L1 minus 6, which by itself is an address, okay? But that is also, the address itself is stored into those 4 bytes. After the calculation, EAX ends up with L1 minus 8. So dereferencing EAX is the same thing as dereferencing L1 minus 8. And it just so happens that when we dereference these 4 bytes, or when we dereference and grab these 4 bytes, okay, looking back at my memory layout, we'll get the actual content. Okay, I cannot move it too much. There we go, that works. Okay. So when we actually do the copying, which 4 bytes am I copying? This is L1 plus 4, 3, 2, 1, 0, -1, -2, -3, 4, 5, 6, 7, 8. So we are copying these bytes into the register. So that means the register will now end up with a value of 0xFF870613. Is that okay? Do you think that is the case? But you never take my words for it. So how do you know that I'm speaking of the truth?
Pig inside the register.
Exactly. Go to the debugger and test it. So I think it might be helpful for me to start another terminal just to do that. So gdb, what was it? Dig. List the program, put a breakpoint on line 10, run the program. Now we are on line 10. So the first thing we want to do is to say, okay, what is label L1? Okay, label L1 is 40084. what is in EAX. Info register EAX. EAX has, oops, this is wrong. Did I?
You didn't relink, did you?
Ah, that's it. Okay. So reassemble. Oh, okay. It remember assembling from a different time. Dig.o, dig.s, and go gdb dig. And then break on the line 10, run it. What is L1? What is in registered EAX? Okay, that's better. Okay. So when you, okay, let me move the screen because you can't see it from down there. Okay, so at this point we know L1 itself is the address 400084 in hexadecimal. We also know that that's L1. EAX, on the other hand, has 40007C in hexadecimal. Forget about the most significant digits. Just compare the 84 to 7C. What is 84 in hexadecimal minus 7C in hexadecimal? It should be 8. Okay? So there are 8 bytes in between, which means EAX is in fact L1 minus 8. Okay? Alright, so we know we're copying from L1 minus 8, 4 bytes into EBX. Single step instruction, it did not segfault. And if we look at EBX, it ends up with FF870613, which is what I just described earlier. So at this point, I can still explain everything that is going on with the program. All right, so now we want to look at this instruction here and go like, okay, but that's not exactly what we want. Because according to what we did earlier, what we want is to end up with 847D as the least significant 4 digits. But right now we have, what was it again? Smart? Yeah, so what we have at this point is 0613 instead of 8470. So what do? We only have a subtraction instruction. Yep.
Like what I personally did was like, this isn't probably the best approach to things like by any means, because it took a lot of fiddling, but like what I did was like subtracted what I got the difference between what I had and the end result, and then try to find a hexadecimal number that was pretty close to that number.
Because the least significant byte can still be adjusted later. So you need to get the most significant byte of the 16-bit adjusted first. So that means, this is what we want, and this is what we have. So you just do a subtraction. Okay, so let's do a subtraction here. So print /x 0x0613, which is what we have at this point, minus what we actually want to be there, which is 847D. So this is 847D. And forget about the most significant parts, okay? We care only about this part here, which is 8196. So we go back to the memory layout and say, do we see an 81 somewhere? Oh yeah, we got a 81 right here. Okay? But you have to be careful, because if there's another 81, then you have to choose which one is the proper one. Because the second byte or the least significant byte is going to be significant. But in this case, I don't see another 81 here. This is the only 81. So that makes your homework assignment so much easier. Okay, this is not by design, it's not intentional. You could have easily have a second sequence with an 81, but it just turns out to be easier. So this is 81. This is what I want to be subtracted from the most significant byte, which means I have to start subtracting at L1 plus 4, which is the byte before this one, because that's the least significant byte. Okay? So now I specify, I go back to the program, go back to the source code, and specify L1 minus 4, I think. Yeah, L1 minus 4 is where I want to subtract. Plus 4. Okay, thank you. All right. So I'm not going to stress and worry about the last instruction. I'm going to get this done first. Let GDB figure out what is the difference between what I need and what I have, and then I'll look for that byte. Okay. So I'm going to save the program. go back to GDB, get out of GDB, come on, get out. Assemble, link, and run GDB again. This time I can stop one line after, or I can just stop on line 16. So run all the way, put a breakpoint on line 16, run the program, and take a look at EBX. Okay, this is what EBX looks like. I got, for the most part, done. Okay, the only byte or the only part of EBX that is not done is the least significant byte. This is 8.3, which is what I have. What I want is 7D. So I can, so what is 8.3 minus 7D? I don't even need GDB, or we should not need to use GDB to figure this one out. Okay, 3 is 3 away from 0, and then D is 13, which is also 3 away from a 0, so the answer is 6. Okay, so we just need to subtract a 6 from this byte, and we're all done. We're looking for a 6, 0, 6 to be exact. Do we see any 0, 6 in the memory layout map here?
Yeah.
There's 1, okay? Now, in this case, if there are multiple ones, they will all work, because we're only getting 1 byte to subtract. It doesn't really care about all the bytes around it. So in this case, that 0, 6 is L1 minus 7, if I remember correctly?
Yeah.
Okay, so, yep.
Are we gonna have to do hexadecimal math like this on a test?
Not really, because you can have your scientific calculator.
I don't think my scientific calculator does hex.
That is not very scientific, is
It's
it?
not.
Not very computer science.
Can I program my own calculator?
You can probably hack it.
So that's a
L1
yes.
minus 7.
If I
Okay,
hack
so,
the calculator, do I get that?
no, the answer is no, you probably don't have to do it. Yeah. But it is, it just takes time to get used to it.
This one does.
Yeah, most scientific calculators can do that, but not all. Okay, so we assemble, relink, and then re-GDB, and this time we're gonna go all the way to check here, run the program, stop here, and then do an EX, IR EBX, and I think that is what we want. Yep, that's exactly what we want. So the homework assignment is done. So the assignment is definitely designed to be kind of convoluted a little bit to make sure that you guys have to figure out, okay, but what is this instruction really doing? So I'm gonna go back and re-annotate the entire program. Well, finish up the annotation because some parts is not annotated yet. So go back here and where's my VI?
You're using a different tab.
Oh, the other tab? Oh, there we go. Thank you. All right, so I'm going to annotate the entire program. So this is a subtract instruction, which is kind of the same thing as bx minus equal to something, but it is whatever is at L1 plus 4. Okay. So in other words, I am subtracting something from bx, but I'm only subtracting the content at location L1 plus 4. Okay, so it is very important. I mean, to someone who do not have any experience with C and C++ programming, the asterisk doesn't seem to be very important. It's like, okay, what is the difference with or without it? But it is, that's the whole point. Okay, are we using that number for the calculation, or are we using whatever content at that location for the calculation? That really is the main point of the homework assignment. And also note that I do not put an E here. This is not a typo, okay? Because this calculation, the subtract word instruction, if it does end up with a carry, it does not impact the most significant 16 bits of EBX. And that's why I have to be careful and only say that this subtraction applies to BX and not EBX. So the next instruction is pretty much the same thing, except it only affects BL. So BL minus equal to whatever is L1 at L1 minus 7. So that's how I would annotate the actual code here. Are we doing okay with this particular program?
Command to assemble to link, is it built in or did you assign it?
Could you ask the question again?
The command to assemble and to link, the not A and not.
Oh, that's just a repeating. That's, exclamation point means repeat the previous command that start with the following letters. You can start with A, if there are multiple commands with A that starts with A, you can say AS to differentiate between those commands. It's just a little handy bash feature. Bash stands for Born Again Shell. Born Again, which is spelled B-O-U-R-N-E, born again, which is not there's no religious connotation. It is the person's name, the person who wrote the shell has a last name of Born, as in Born identity. and because the Born shell is one of the rehash of all the previous shells, and that's why it's again, and that's why it's called the Born Again shell, which is otherwise known as bash.
So
yeah.
do you think they get these names by coincidence, or do you think they just think long and hard on how they're going to make these work?
Oh yeah,
Step one, change
that's
your name.
definitely how they do it. Like lame, L-A-M-E, is lame, ain't, MP3 encoder.
Or like Twain?
Yep, or wine is not emulator.
I love that emulator.
It is not an emulator. It is just a library that your program is running with. Okay, so are we okay with this homework assignment? Are we ready for the next one? Because I know you guys have time on your hand next week. There's something called spring break. Okay, so let's move on to the next homework assignment.
I don't believe in doing homework over spring break. It's
Spring
against my
torture.
religion.
Oh, that sounds like a device to me. A torture device utilizing springs.
Enough pressure, you could pretty much break anything.
Oh yeah, springs are very dangerous.
The more you press them, the more they press back.
Exactly, and there are springs that are very big and have a lot of, store a lot of energy. All right, so this is, string count, which is the next homework assignment. So these are the instructions. Create a folder called string count and place the source code string count.s. Remember, everything is case sensitive, so I don't want to see anyone turning in file names that are alternatives of what is described here. Use the following as a template for your implementation of string count. In other words, you are strongly recommended to copy and paste this as a starting point. This part here is really just allocating 256 bytes. This one is just allocating 1 byte and initialize it to 0, which is not really that important. Then we switch back to the text segment, which means these are the things that we can change, and this is the part where we do not change. Underscore start, there's a missing colon here, so when you assemble the program and it refuses to do that, you know how to fix it. Move $string into EAX, which means EAX is now storing the address of the first byte of the string itself. Move B, move byte, kchar, okay, key character, which is this one here. And you can see that the first one has a $sign, the second one does not have a $sign, which means the second instruction actually moves a particular character from memory into BL. So your code is so you put your code over here to implement string count. I'll describe what it does. And you want to make use of EAX as well as BL in your code. By the time we get to check here, ECX should have the number of characters matching BL in the null terminated string. Okay? All right. So let's go through some examples just to make sure that we know what it is supposed to do. So let's get out of here. Let's get it here. Okay. So if the string is my name, okay, tag T A K, and then a null character at the end as a terminator, okay? And the byte that you're looking for, which is kchar, turns out to be A, okay? Then ECX should end up with a value of 1. ECX should end up with a value of 1 when your code is done, because it is counting the number of lowercase a in the null terminated string. If I have any garbage after this, okay, Z, question mark, and whatever, that should not matter because it's a null terminated string. Okay. But if I'm looking for something that is not in my name, like B, well, then you just say there's 0 of those in my name. Is that okay? if my name is really kind of awkward and it has 2 A's in it, okay, and you're looking for the character A, then the count is going to be 2. In other words, ECX is just a counter counting the number of matches of a character in kchar in the null terminated string. Are we understanding what the program is supposed to do? Okay. So now the big question is, but how do I test this program? Because the program itself does not give me anything to start with. If you look at the source code here, I'm just allocating 256 bytes. I don't even bother to initialize it. So how do we get something to test with this particular program? All right, so let's go ahead and give it a try. So I'm going to do a copy here and go to a terminal, paste it so that we can give that thing a try. So remember, you have to create a folder called string count. Go to string count. This is how I would do the copy and paste. I use a cat command and redirect it to string count.lowercase s, and then I paste on the terminal. You can do this only with PuTTY, okay, not with a console main window. Control D to stop at the end. So now I have the program pretty much, copied into the source file, just like that. Is that okay? All right. So with this program, it doesn't do much. I'm going to put a breakpoint at check here, which is the exit code. So we'll go ahead and do the, remember I have to fix one thing because I forgot to put a label, colon, after underscore start. So you have to do that too. All right, so the first thing to do is to assemble g stabs -o string count.o string count.s. Link the program to string count.o, and now we can run the program. But before I run the program, I am going to give myself a test string. In other words, I'm going to give myself a test case so I can do this. Okay, vi can do this. So if I don't want anything too fancy, I can just use just my name here. But I don't have. Oh, I do have a repeating character u, so that I can use that as a as an indicator. All right. Oh, but wait, hold on a second here. This does not have a null terminator. Okay, whatever test case I want to use needs to have a null terminator. So in VI, there is an easy way to put in a null terminator. You basically append to wherever you want to insert the null terminator. On the keyboard, you type Control-V, Control-At, and that is a null byte. You can do that in VI, cannot do that in Nano. Nano doesn't have this ability. Okay, so I save it. Oops, need to give it a save file name to save to. I just call it test.0. This is my first test case, just like that. And if you want to create a test case for the character itself, you can do that too. So I'm going to say test char.0, and I'm looking for the letter U. Okay, that's it. Now this one is a little bit trickier because if you look at the size of the test char file, okay, I'll do an ls-l, that will show me the size of that file. It has 2 bytes instead of 1, okay, even though it's supposed to only have 1 byte. That's because the second byte is the line feed character. Okay, I really don't want it to have a line feed character. So this may not be the best way to do it. Let me remove this file. Okay. Instead, what I'll do is this. I will have a empty line in this file. Then the empty line, new. Okay, that's 1 character. It has an empty line right now. And then there's a program called hexedit, H-E-X-E-D-I-T. Not sure whether it's already, okay, it's not included yet, so I have to install it. You can do the same thing with your emulator. So you do a SU and you enter the password for root, and then you say aptitude install hexedit. It's a hexadecimal editor, which allows you to change any byte of any file to anything. Yep.
I tried with SU, and user is not the password for root.
The root password is beer.
Beer.
Yep,
How do
root
you
beer.
B-E-E-R?
Yeah, B-E-E-R, lowercase, all lowercase. Root beer.
Sure, that's the
Yeah.
reference.
Alright, so now that I have that program installed, I can do a hex edit and then the name of the file, which is testchar.0, and it has a 0a, which is the line feed character. I want to change that to lowercase u, so I have to figure out what is lowercase u now. Okay, you guys can look it up, in an ASCII table, but you can also count to it. A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, okay, that's 21. So we have to do this calculation, 60 in hexadecimal plus 21 in decimal. Well, that doesn't work very well, does it?
What's 1.5?
How about that? Because 21 is 16 plus 5. This is the 16, this is the 5. Well, that's not too bad. 75 in hexadecimal. Okay, so we'll go ahead and change the 0a to 75, and then we can save the file. To save the file is Control X. It will ask you, unknown command. Okay, how do I save it then? Control X. Save changes? Yes. Okay, there we go. How do I confirm this? Cat. Okay, cat testchar.0. Cat is just kind of like type. So you can see the extra U here. That is the content of the file. If that bothers you, you can also use hex dump, okay, which is only for dumping, to display the content, -C testchar.0. You can also see that 75 as an ASCII code is actually lowercase used as a character. So I have just confirmed that part, okay? Now the question is, okay, now that we have specified the test cases in individual files, how do we get these into the memory space of this program so we can test the program, okay? So let's go ahead and find out how to do that. Okay, use GDB to get into the program first. I'm just going to put a breakpoint at check here, okay? Just so that I can run the program. You cannot put anything into the program unless it is running, because otherwise there's no process. Without the process, there's no memory. And as a result, if you want to do anything, you have to run the program and stop at the breakpoint. So the first thing I want to do is to find out, okay, what exactly are those 256 bytes at that location, which is called string in this case. Cannot access memory at location 0. Okay, did I use the wrong labeling? Let's double check. Wrong folder. Lowercase s. Okay, there's string. I did not use the wrong name. It's the right name. So why is it refusing to go take a look there? Maybe string has some other meaning. Let's try kchar. Cannot access memory at address 0. Tell me what is string. String is 0. Tell me what is kchar. It is also 0. That is weird.
You can try with 8 bits to start with.
Hmm?
You can try with 8 bits to start with. I think we're going past the end of the file.
Oh. No. When I print the label, that should give me the address of the label.
Yeah.
So maybe I forgot to do one thing. Did I link the program? No, I did not. Did I link it over here? No, I did not. Okay, so that's why.
Running off the
Okay, do a ls. No, I did link the program. Otherwise, there wouldn't be a string count. Curious.
Did you read?
Well, let's see. I'm just looking at the memory layout. This doesn't look. Okay, there's a string count, there's a string, and then kchar. So they are supposed to be around. They're allocated, but the labels are not found when I use the debugger. I'm baffled.
When's this due?
So putting a
When is this
pause
due?
on
When's this
this.
due? Can we?
Sorry?
So are we putting a pause on this assignment for this, or at least bumping?
Well, I
due
still
date?
got a few minutes.
Fair
I
enough.
got 2.5.
Let's do Tuesday after break.
Yeah. Well,
Assuming it works.
this will work in the simulator. I think it has to do with, this is a 64-bit machine, and it's supposed to be a 32-bit program. Okay. Okay. So let's do it in 32-bit mode.
Here, you can just run the other emulator for 32.
So we'll do it in using the emulator. So let me start up this emulator first. Okay, so let's see how quickly we can do this.
Rushing against the clock.
Start.sh. Start the emulator. And my emulator is faster than yours.
Tell me
Notably,
about it.
I fell asleep waiting for mine the other day.
I don't need an emulator.
I was like, just close my eyes for a second,
See,
wait for
mine
it
is
to
done
load,
already.
and I woke up.
Oh.
It was the next day.
Okay.
Because you're using an accelerator, right?
Yeah,
you're-
because I'm using
Because you
Linux,
can.
so the accelerator works.
Oh.
Okay, so I'm gonna well, I don't need to tarp the whole thing, I just need to send that one file over. scp-p2200, user at localhost. Oops. No, I can specify the file name first. String count.lowercase s2, that, and I'll do it in the temp folder. And user, go, it's copied. So we go to the local machine. This is the virtual machine already. So go to the temp folder, do a AS. LD and GDB. There we go. Put a breakpoint at _start. Run the program. Print what is string. Kchar. Okay, wait, hold on. Kchar is okay. So that means X should work. So x/1x1dx string.
Okay.
Okay. Maybe it's just a variable name thing. Okay.
I'm sure you'll figure it out by Thursday.
By
And we
end
have
of
the
spring
lab
break.
time, okay? The class is not over until 10 o'clock. So technically I can do this until 10 o'clock.
You're
again.
recording the lab, right?
Yes, I am.
Okay.
No, I'm not recording the lab, I'm just doing this real quick here. Let's just call that string A. Okay. Assemble, link, GDB. Oops. Assemble, link, undefined reference to string. Oh, of course, because I changed the definition and I didn't change the other one. Okay, string A. Okay. Assemble, link, GDB. Put a breakpoint at _start. Run the program. Tell me what is string A. Tell me what is the address of string A. There we go. So we just have to put the address off because the symbol is confusing. It's confusing GDB, so you have to use an ampersand to refer to the location. And I think that is also the case with the 64-bit version. In other words, if I go back to the 64-bit version here, still be able to do the same thing. So put a breakpoint at underscore start run and print the address of string. There we go. It does work. I just have to add an ampersand to it. Okay, so getting back to how to load all that stuff, the content, the command to use is called restore. I know it doesn't sound like it has anything to do with this. So help restore, it will tell you how to use this. So restore the content of a file to target memory, which is actually what we want to do. So the way we do it is to specify the file, offset, start, and end. And so we'll go ahead and do this. We'll say restore, specify the file, which is test.0, to the offset. Remember, there's one little thing that's nagging me. Okay, offset 0, and we call it string A. No, string. The address of string, actually, because the address has to be that. It's not a recognized. Okay, I know it's what? I think you have to specify binary. No test in current context. Okay, restore file name, binary, bias, start, end. Okay, one more time. Restore file name, test.0, binary, ampersand string. There we go. All right, so we got it stored. The next thing is to test it, okay, to make sure that the string is actually what we are supposed to be over there. So we can say x/ my own name, right? So it's TAK. Okay, we'll just give it too many bytes. 20bx at that location, which is the address of string. Okay, so this is supposed to be TAK space Ouyang, so that looks right to me. And then the second thing you have to do is to restore the character that we want to copy, and that one is being stored to kchar. There we go. And we want to double check that really is the case. So we want to look at whatever is at kchar as one single byte. And that's 75, which is the U. You can see there are two U's in my name. There's one and there's the other one. So now you have all the tools that you need to get started with the homework assignment. Are there any questions about the homework assignment?
Can you show us once more how to get the string, how the string is involved in the .s file?
Sure. So the string, there are two ways to specify the string. The way I did it is to use VI, which is, and you need to have a null terminator because you're supposed to store a null terminated string into that space. So whatever you load from the file needs to be null terminated, needs to have that byte of 0. So this is how I did this. And then the other file, which is test char, starts with a single character, and then I overrode it with whatever I need to override it with.
Can you show us that file?
Mm-hmm. Now, I can cat it to you, because that's the more truthful representation. It is just a single character.
And you made that by declaring it in Vim and then using hex edit to make sure it's
Yep.
just that one character?
Yep, exactly.
Okay, and then how do you get those two into the assembly code?
Okay, so to get it into the assembly code, you go to the debugger. You have to start running the program first, and then you use the command called restore. So restore file name, and then you specify the location where and then you specify binary, and then you specify the location where you're restoring it to. The first one is going to restore to string, and then the second one restores to kchar. So the character is restoring to the label kchar itself. So now I have the string and the character to be loaded into memory, and I can start to run the program. So I recommend doing this using a script so that this way you don't have to type and remember all these commands. GDB is capable of scripting. So let's see. Okay, type help in GDB, and it will give you user-defined commands. And what we want to do is to use a script. And let's see which one looks like a script feature. Or we can just Google it. GDB run script source. Okay, so there we go. You just create a file and then you source it. Let me show you exactly how to do it. Okay. Even within GDB, you can actually escape out of the shell and do something. So I'm going to escape out and make my source file. So I'm going to call this test.gdb. The extension .gdb is not required.
The exclamation mark is how you get out of GDB to go back
Yep,
to shell.
to shell out. Yep. So now you say restore test.0 binary to the address of string. Restore test char.0, which only has one single character, binary to kchar. Okay. So you can even do the other stuff too. You can say put a breakpoint at _start, and then run the program, and then do the restore. But remember, whatever you type here, every time you source, it will rerun all of these things. So if you have a breakpoint if you set a breakpoint inside the script file, it will set new breakpoints every time you run it. So that may or may not be what you want to do. Okay, but I'm just illustrating the point here. Okay, because I already have the breakpoint set up, I'm not going to do this. Just these two commands. I get out of the VI editor, and we get back into GDB. So in other words, I never left GDB. I really just kind of call a shell to do the editing. So now that I'm in GDB, let's run the program again from the beginning. So now I can reload all the content, and the command to do that is just source test.gdb, and what that will do is kind of like a pound include interactive, where it will bring in the content of test.gdb and run it right now. So it's good for testing programs, because this way you just have to do it once. Once you get it right, every single time you want to test the program, just source it again. Is that okay? All right. So I'm going to stop the lecture at this point. I will be at the lab. So if you think you might need some help setting this up, go to the lab and I will help you out.